İyi günler değerli katılımcılarımız. Seminerimize hoş geldiniz. Ege Hazır Giyim ve Konfeksiyon İhracatçıları Birliği tarafından düzenlenen seminerler dizimize bugün de Atina West Attica Üniversitesi'nden Profesör Doktor Savvas Vasiliadis ile devam ediyoruz. Katılımlarınız için öncelikle teşekkür ediyorum. Bu arada bizi kırmayarak bu seminer organizasyonunu kabul eden Profesör Vasiliadis'e özel teşekkürlerimizi iletiyoruz. Kendisinin bugünkü sunumu, konuşma konusu akıllı tekstillerin serüveni. İlginç bir toplantı olacağını düşünüyorum. Savas hocamız bize yeniliklerle ilgili, yeni teknolojilerle ilgili çok kıymetli bilgiler verecek. Şimdi ben yine her zaman yaptığımız gibi çok kısa bir şekilde konuşmacımızın özgeçmişini size takdim etmek istiyorum. Gerçi kendisi de muhakkak bilgiler verecek ama ben yine de bir özgeçmişini özetleyeceğim konuşmanın başında. Atina'da bulunan West Attica Üniversitesi'nde öğretim üyesi olan Profesör Doktor Savvas Vasiliadis, tekstil alanında diploma, elektronik alanında lisans, elektrik ve bilgisayar mühendisliği alanında da yüksek lisans ve hesaplamalı modelleme alanında doktora derecesine sahiptir. İlk kariyeri tekstil ve otomasyon sektöründedir. Akademik kariyerinde elektrik elektronik mühendisliği bölüm başkanlığı, uluslararası ilişkilerden sorumlu rektör yardımcılığı, West Attica Üniversitesi senato üyeliği ve kurumsal Erasmus koordinatörlüğü görevlerinde bulunmuştur. Balkan Tekstil Mühendisleri Derneği'nin ilk başkanıdır. Çok sayıda ulusal ve Avrupa Birliği destekli Ar-Ge projesine katılmıştır. Araştırma alanları arasında tekstil modelleme, çok işlevli malzemeler ve dijital sistemler yer almaktadır. 200'den fazla bilimsel makalenin, 15 kitap bölümünün ve teknik el kitaplarının yazarıdır. 2022 yılından itibaren de Tekstil Üniversiteleri Birliği'nin Altex'in başkanıdır. Kendisi sunumunun başlangıcında Altex ile ilgili bilgiler verecek ama ben çok kısa birkaç kelimeyle Altex'i size açmak istiyorum. Yanlış hatırlamıyorsam Altex yani Avrupa Birliği'nde bulunan Tekstil Üniversiteleri Birliği 1988 ya da 89 yılında kuruldu. Pardon 90 yılında kuruldu, 98 yılında kuruldu. Ve bugün çok sayıda üyesi olan bir kuruluş, bir network daha doğrusu ve aynı zamanda Türkiye'den de 4 üniversite halihazırda bu network'e üye durumda. Evet, ben şimdi sözü Profesör Savvas Vasiliadis'e bırakmak istiyorum ve güzel bir toplantı olmasını istiyorum. Buyurun. Profesör Savvas, söz sizin.
Okay, thank you very much for the introduction. From this position, I would like to thank your association and especially my colleague, Professor Hüseyin Kadoglu, who has organized this event and invited me. I'm really happy to be with you. And what he has not told you is that my location is in Athens. However, I spent a lot of time on the island of Mytilene next to you. And moreover, I would like to tell you that my origin is from Adana. I hope you know the city. And this brings me more closer to you. All this background, I'm now on the island. I'm just 50 kilometers from you. And imagine that we have very many common roots. Give me a second. Have something here saying confirm your speaking language. This should be English. I have to confirm my speaking language. I hope not. Okay. In fact, I was in a strange situation because the audience was not only engineers, so I had to give you a presentation that is not strictly technical. It should be a little bit more generic. And I hope this will be fine for you. So in the beginning, I will start with the short presentation of OTEX. OTEX is the Association of Universities for Textiles. As Professor Kazdoglou said, our association is is about 30 years old, and we have members from more than 50 universities all over the world. OTEX started as a European association, and slowly it has been open to the whole world. So we have members from all the continents of the globe. For this period, I am the president of OTEX, and I'm really happy to coordinate this fantastic community of the textile universities. So OTEX is a global network. We have members from now it's 37 countries. Every day we have more and more members. Now we have 52 universities. And now we opened our association to the research institutes as well. So we have our first research institute participating. And you can see here the distribution of our member universities all over the world. You see, we have a concentration in Europe because this was our first area of activity. Then we expanded in the other continents as well. Every year we organize the World Conference in different places. In 2023, the conference was organized in Melbourne, in Australia. 2024 in Liberec in Czech Republic. This year, in June, it will be organized in Dresden. It's combined with the celebration of the 100 years of the textile department there. Next year, 2026, the conference will be organized in Casablanca in Morocco. And after 2 years, the conference will be organized in Monastir in Tunis. So this is a very big event. And we are very happy that now it's maybe 25 years now. It is a very big event for the textile scientific community. Another activity of OTEX is the publication of the OTEX Research Journal. This is a scientific journal published by De Gruyter, the German publisher. All the scientific part is under the control of OTEX. De Gruyter is just providing the services of the publication. We are highly interested for scientific articles by any means, from industrial research to pure scientific research. And our journal has an impact factor, is fully cited and it's really one of the most important journals in our site. Another important activity is the WE team, the World Textile Engineering Advanced Master. Again, university participates in the new phase of the WE team. And it's a very interesting master course for young people because the first semester is always organized in Belgium, in Ghent. The second semester is organized in Greece, France, and Spain on a rotational means. The third semester is organized in Sweden and Japan, in Kyoto. And in the fourth semester, the student can choose any country for his, her master thesis. So it's a master course that really enables the international experience of the young people. So a student in this master course will spend 2 years in 4 different countries. So by the end of the course, a part of the scientific issues, the student will be really full of this international experience. And not only in Europe, but also in Japan. So this master's is organized in a sense of modules. Every module has a duration of 1 week, and it is equivalent to a full master course for 1 semester. So what it happens is the students go, for example, now they are in Athens by coincidence. They go in Greece, and they have a different professor every week from any other country. I think the only Greek professor giving a course in this semester, it's me. The rest, 10 professors come from different countries. And this happens for the 3 semesters. The students move for 1 semester, for example, in Japan, and professors from all over the world go there for 1 week, give the course, and so on. It's also a very nice experience because the students have the opportunity to get taught from the most specialized professors all over the world. I'm afraid that sometimes I speak too fast, so I stop a little bit to help the interpretation. Another activity we have is that we appoint every year the Lifetime Achievements Award. This is an award to mature scientists with exceptional contribution in the textile science and technology, and with contribution to OTEX operation and development. The award is appointed in a special session in the World Textile Conference every year. Again, university has organized, I don't know, 2008, it was this one, the OTEX World Conference in Cheshire. And in that moment, the Lifetime Achievements Award went to Professor Isik Taraksioglu. Last year, the person honored by this award was Professor Kanji Kazivara from Shinshu University, a very famous scientist in our field. Next to that, we organized students' competitions. Recently, we had the OTEX Design Action. We asked the international students community to design for us a tie, a scarf, various objects, and so on. And the coordinator of this action was Dr. Tisinova from Liberec. And we are now ready to appoint the 5 awards for this design competition to the young designers. Also, we support the scientific monographies. We ask our members, our specialized members, to write a monography in hot topics of our area, and hoping that these monographies will help the young scientists from all over the world, open access, to join these concentrated knowledge in specific fields. Professor Adaferi from Politecnico di Torino is coordinating this action. If you want to know more about OTEX, have a look in this link, otex.org, and you will get informed about everything happening in our community concerning conferences, events, and so on. So we will stop the presentation of OTEX now, and I will go somehow stop share. No, your screen share. Yes. I will go now to my main presentation. Yes. We will discuss a little bit about the smart textiles. And I call it adventure because it's really a way in the time that it's very interesting. And we will see why. If you just to give you an indication of my place, I'm located in Athens. West Attica is the less developed part of the city. So the government was very proud to establish a university there, showing to the people that, yes, we care also for the less developed part of the city. In fact, it was an action because of the financial crisis where the international institutions suggested to reduce the number of the universities. And 3 universities were merged, and we have established this University of West Attica. The name is new, but the universities are old. And our logo is the philosopher Plato, because in the area where we are located, it's supposed that it was the place where Plato was teaching. So we call it Plato Academy in this time. So Plato Academy, University of West Attica, all combined together today's activities. So let's have a short introduction to the terms. We consider that smart textiles are textiles that can sense and respond to stimuli, to changes in their environment. This was really a fascinating idea because by the introduction of the smart textiles concept in our lives, immediately textile engineering left its de facto isolation and started to interact with electrical engineering, mechanical engineering, material science, and so on. So smart textiles is not only something that give us a certain direction in the research, but also it's very important structurally because it opens textiles engineering to cooperation with other disciplines. Within smart textiles, we have some categories. The passive smart textiles, for example, they just change their properties according to the stimuli. For example, we have the shape memory materials where upon a certain stimuli, it changes its shape and then it comes back when the stimuli stop. We have the active smart textiles, where we have sensors and actuators, so that we connect information coming from the environment and to create actions according to the scenario of reaction. The ultra smart textiles, this is something very extreme as a term, are here just to tell you that practically we have computational units and communication units. We receive the information, we react, and also in the same time, we can be adapted to the new conditions, or we can transmit the information via the internet to the cloud and so on. Let's have a technological overview. Smart textiles, one of the application field of smart textiles is the health. So we have a strong link to the healthcare applications. And this is because clothing is in direct contact with our skin. So we cover a big part of the skin of the body. And so it's a very nice substrate to have sensors, wires for interconnection, but we need to have to care about the comfort, the easy care, and to have the feeling of the disappearing electronics. Electronics must not be visible, must not be found on the clothes. So we need to have them integrated into the structure. And I show you here the head of the health, the goddess of the health. The next one should be Asclepius, maybe the god of the medicine, and Hippocrates, the famous doctor. We need sensors, and sensors are mainly textile electrodes for our health applications because we need to capture the signals of our body, electrocardiograph, electromyograph, whatever. So we need to have electrodes friendly to the skin, to be lightweight. That means to have a wear resistance, to use it for a lot of time, to be ductile, to be washable. I mean, we need to have electrodes that they can resist to the wear, and at the same time, we have to think about the comfort. Here we have some problems, and they are not yet solved, because if we need to have the electrodes in very good and direct contact, the shirt must be very tight over the body, and this reduces the comfort. On the other side, we have to be sure that the electrodes are positioned in the same place. If I take it out and then wear it again, the electrodes must be positioned the same points, because otherwise we receive signals that will be not comparable. So we have positive and negative issues concerning the position of the electrodes on the human body. We have a lot of activities concerning the electrodes. We have really very good quality electrodes. Adidas has developed a needed sensor for monitoring the heart rate. And we have many researchers that they really do a very, very good job. We have tested a lot of electrodes like that, and they are really very good. Another application field of the smart textiles is the personal protective equipment. The personal protective equipment means that a human is exposed in a harsh environment, an environment with strange conditions, so it has to be protected. That means military service, firemen, and so on, rescue teams. Since the human is exposed to the very strange, very hard environment, we need to protect mechanically the body, and in the same sense, we have to collect information from the environment in order to protect the person wearing this personal protective equipment. And for sure, you have seen some applications, even in Turkey. We had firefighters costumes with a lot of sensors. There are very hard standards ruling the construction of the costumes, and it's really a big challenge to incorporate all these materials or these sensors and wires in this protective costume without violating the standards. So you have protective costumes for medical purposes, for electric purposes, and so on. Thermoregulating materials is a very interesting issue. We try to affect the microclimate imposed by the clothing. Clothing creates a microclimate for the human body. And always we dream of a costume that it's heating or cooling the human body. There are attempts in this field. We have the PCMs, the phase-changing materials. You have in a hollow fiber, for example, volatile liquid, and by the heating, the liquid becomes gas and absorbs energy, the thermal energy. That means you have the cooling feeling. And in the backwards, when the human body becomes cooler, then the phase-changing materials comes from the gaseous to the liquid phase, and you have energy given to the body, heat energy. It's an interesting issue. Also, we can use Peltier elements that use electric energy to heat or cool the body. This is under research phase, is not yet ready for application. So we need to have in this protective equipment power and data transmission, sensors, and very important is to have these end-life indicators, because we have to know if the equipment is active, is operating well, or it's coming out of the life if the batteries run out, or sensor is not operating carefully, correctly. And this is very important because any misoperation of the costume means that it brings in danger the person that wears it. What are the future trends? we need to have higher degree of integration. We don't like to see electronic parts in the textile items. That means we will be happy to have textile-based electronic components. We can use textile materials as resistors, as coils, as capacitors, even as transistors. That means that the research can go in this direction to eliminate the use of the electronic materials and to focus mainly on textile-based electronics. We need to have simpler care procedures. That means we don't like to have electronic parts to be disconnected in order to wash the item in the washing machine and then to reconnect and so on. Of course, higher durability, less damages over the use. Always higher degree of comfort. The increased textile character of the components, as I said, and of course, lower cost. Now, concerning the future terms, we come to a very interesting field. There are some consulting companies publishing the future trends for the market of the smart textiles. And it's really very optimistic and very enthusiastic. We have incredible numbers. For example, for 2024, it was foreseen that we should have a market of something $9 billion and so on. A lot of billions appear here. And unfortunately, I cannot see in the market the respective products. And I was really very skeptical about that. How it comes to have such an optimistic aspect when we don't have the respective signs from our market. You know, many times we start our discussion about smart textiles showing a graph like that, that look, the perspectives of the market are really explosive, exponential. What it shapes the future is the market, of course. If the market expects high volume of sales, and that means high profit, then there is a direction of research activities, an increase of the research activities and the industrialization phases. And how an investor will convince to direct his resources to the smart textile sensors? By fortune teller or by scientific discussion or by the indication of the profit. And what an ideal, let's say, investor does is to read one of these market research reports. Probably all of you know these consulting companies publishing this sectorial market research. And for smart textiles, it's really, all of them are really very, very optimistic. Incredible numbers. They were discussing about $5 billion to $4.7 billion, $1 billion here, $1 billion there. And an increased trend by 30%, 25%, 33%, things like that. I was really surprised by reading these research, market research reports. I took one just as an example from Mordor, for example. And it was, it had an expectation of 2025 for 7.5, not dollars anymore, million units. And the increase was for 2030 foreseen for 12 0.6 million units. Now the $1 billion became million units because probably also these consulting companies realized that what they said in the past in reporting million and $1 billion was not exactly true. So they changed it to the million units. What it does mean, I don't know. And they base their activities, their estimations on some companies, IOU, Adidas, Nike, Thermosoft, Cologne, and so on. And I had a look on these companies, where I have seen that Cologne, for example, is a very interesting company producing advanced materials, but I have not seen here a product directly connected to the smart textiles. AIQ is another company that says that, look, come to us with your question and we will try to develop smart textiles for you. They don't sell smart textiles. Nike, I had a look at Nike's website, and the most interesting thing I found is this small pocket for the mobile phone. I mean that it's really a lack of smart textiles products in the market. This is true. We were very optimistic 10, 15 years ago when we started working with smart textiles. And we did really a lot of work in this field. And as I said, that it was not only the partial results, but the most important thing is that we textile people started cooperating with other disciplines. And I try to understand where this optimistic point of view came for all these consulting companies. I could not understand really how they have made these forecasts. Finally, I have seen from a company called Atos that they have correlated the scientific production, the numbers of the papers produced in the market, in the scientific community, with the market strength. And I think this was the mistake. We had a lot of scientific work, but finally we didn't have the respective product in the market. This is the reason I discussed about the adventure. It's interesting that we have really a very interesting issue here. And I had a look in the scientific publications concerning the electric cars. It's an increase. And the estimation of the market is this one. That means that there is a time delay between the scientific work and the market. Let's say here is something like 10 years. There is scientific work years ago, and then the product comes in the market. Another example I had is the 4G networks, when you have a lot of scientific publications, and then after, now the time interval now is shorter, it's something like 5 years, less than 5 years, and you have the products in the market. And this is the indication of the scientific publications in the smart textiles area. And these consultants probably applying the same philosophy, they were expecting that after maybe some years we will have a lot of products in the market. That means a lot of money, $1 trillion there, and so on. But this is not happening. So this is what they expected. This was the blue line is the reality, are the scientific papers, and they were expecting something like that. Exactly as it happened in the electric cars or for the 4G networks. I did the same for some other products as well. And they follow, there is such a trend. You have a boom in scientific work, and then after that, after a time, you have the products in the market. But here has not happened something like that. look at here, we have I have the various consultants and their estimations. All of them agree that they will have really a very big increase of the sales of the market. But it's not true. Until today, we don't have really smart textiles in the market. It seems that it's likely that there is a relationship between the published scientific papers and the future market trends. In many cases, the volume of the published papers is an instrument for the prediction of the market volume. The time lap is depends on the characteristics, on the complexity of the subject. Smart textiles here have not yet fulfilled the previous rule, either because the time needed for their integration to consumer products is long, as you have seen for the 4G networks, the time was short, for the electric cars was double. Maybe we're in the case of a longer period. Or because we have to use acceleration procedures to increase the scientific work foreseen, to use bottom-up design, to start from the idea of the user and to develop the smart textiles, not to start from the top to the bottom. For example, I have a fantastic material having these abilities, these properties, and then I try to find an application somehow. So we need application-driven research. Also to use the co-creation principles, that is a modern point of view, enabling the inclusion of the various stakeholders in the research activities, starting from the engineers and going up to the social researchers. That means to include the more global philosophy in the research activities. We have to remember that we discuss here about textiles. That means textiles means high complexity area. Many materials, many structures, many design concepts, many application fields. Very difficult handling of all these issues. Just to remind you, I'm okay in the time. Or should I make it fast? Anyway, I continue. Just to remind you that a civil engineer, mechanical engineer, a naval engineer, if he has a technical problem, he has to design a new building, a new boat, a new submarine. They have fantastic scientific engineering tools in order to make all the calculations. They don't need their pencil and their paper to calculate the behavior of the U-boat structure. In our sector, in textiles, we don't have really powerful tools like that, generic and global tools like that. Why that? Because yes, we deal with very difficult materials, non-linear materials, non-linear structures, very complex materials, very complex structures, and it makes the analysis tools really insufficient. So we have to be familiar with the difficulty of our field. And also add on to this, we have to remember that we have certain restrictions. We need to have a comfort. We don't want to wear something that is like a medieval armor without the ability of move. Aesthetics, we need to have a beautiful clothing item. We have to have a simple care procedure. I get mad if I buy something and it says there you only dry cleaning. Why only dry cleaning? I want to put it in my washing machine and to be okay. But if you put restrictions like that, we make non-friendly behavior for the users. Now, in order to support to strengthen the way to the smart textiles market, obviously we need more intensive research, more targeted research, more cross-disciplinary research. That means long time or more money. And recently I was in Japan and I was surprised by the decision of the Japanese government uh, uh, turning the research from the technological, let's say, point of view to the scientific point of view. This is indicated by the renaming of the Tokyo Institute of Technology, a very famous technical university in Tokyo, and now is the Tokyo Institute of Science. Maybe our research in our materials has reached a certain limit, and we need a very important push in order to obtain the characteristics, the properties we like. And this is not anymore on a technological level. We need maybe more effort in the scientific level in order to gain benefits from the core of the materials. This was my thoughts about the smart textiles. Although the life is very difficult concerning the today's situation, I'm really very optimistic because we have the active market. That means we have billions of people around the planet that they wear clothes and they would like to have more properties connecting with the clothes. So we have the market. We don't create a new ice cream or a new, I don't know, video game, for example. We discuss about the clothing items simply with enhanced with add-on properties. So the market is there. What we need is to have reliable solutions, reliable designs for this market. So I'm optimistic. However, what we discussed indicates that there is more effort needed and more cooperation and more research. And also in another philosophy, it means that this cross-disciplinary research is something new. It's not so easy to carry it on. So with these conclusions, I would like to end my presentation and to thank you for your attention. And I hope that the interpreter is not sick because of my fast speaking.
Evet, Profesör
Thank you very much. Thank you.
Profesör Vasilyadis'e bu yapmış olduğu güzel sunum için teşekkür ediyorum. Gerçekten akıllı tekstilleri bizi derli toplu bir şekilde özetledi. Ümit ediyorum vermiş olduğu bilgiler katılımcıların açısından bir soru işareti uyandırmıştır en azından kafalarında. Yani farklı tekstillerin de olduğu, dünyada yeni gelişmelerin neler olduğu konusunda bu bilgileri aldık. Tabii ülkemiz açısından bakacak olursak bizde büyük bir geleneksel tekstil üretimi var. İşte teknik tekstillerin üretimi de başladı. Hatta teknik tekstilleri ihraç eden bir ülke konumundayız. Ümit ediyorum ki bu akıllı tekstiller konusunda da çok kısa zamanda firmalarımız bir takım girişimlerde bulunurlar ve bunların da ihracatçısı durumuna gelebiliriz. Ama burada tabii daha böyle bir bilgi yoğun teknolojiler, daha fazla araştırma gerekiyor. Evet, sanırım seste bir sıkıntı olmuş. Ben biraz daha yüksek sesle konuşmaya çalışacağım. E, Profesör Vasilyadis, herhalde çevirmenizden gelen İngilizce çeviri duyuyorsunuzdur. Bir sıkıntı var mı? Bir kontrol edebilir miyiz? Sanırım Profesör Vasilyadis çeviri duymuyor şu anda.
Yes, yes, I know.
Tamam.
I cannot hear him as well.
Okay.
I hear you very well, but not Hussein.
Evet. Bu noktada tabii firmalarımızla üniversitelerimiz arasında belki daha yoğun işbirliklerinin de olması gerekiyor. Tekrardan ben Profesör Vasilyadis'e bu güzel sunum için teşekkür ediyorum. Şimdi katılımcılarımızın var ise sorularını alabiliriz. Burada bir soru giriş butonumuz olacak. Buradan sorularını yazarlarsa biz Profesör Vasilyadis'e bu soruları ileteceğiz. Evet efendim, sorularınızı bekliyoruz.
In the meantime, I have to tell you that I started my career as spinning engineer, and unfortunately, if I'm correct, now in Greece there is just one spinning mill. So I'm very jealous when you say that you have a lot of textile industry there. So I miss the smell of the cotton, believe me.
Evet, sizi o zaman sık sık Türkiye'ye davet ederiz. Bu kokuyu alabilmeniz için. Güzel kokuyu.
I will be really happy. I will be really happy.
Evet, evet belki katılımcılarımız soruları düşünürken ya da kafalarında tasarlarken ben Profesör Vasilyadis'e küçük bir soru yöneltebilirim. Şöyle, e, şimdi akıllı tekstillerin üzerinde bulunan elektronik donanımların çalışması için muhakkak bir e, elektrik enerjisi gerekiyor. Bu gerekli olan enerji farklı metotlarla sağlanıyor. Mini bataryalar vesaire kullanarak. Ama benim bildiğim kadarıyla Profesör Vasilyadis'in bu konuda da çalışmaları var. Örneğin vücut hareketlerinden yararlanarak elektrik enerjisi üretimi vesaire. Yani burada akıllı tekstiller için enerji ihtiyacının nasıl sağlandığı, bu konudaki yöntemler neler, birkaç cümleyle bunlara da değinebilirse ben mutlu olurum.
Yes, it is a core question because any device must be powered. It's like the food for the humans. It is very interesting that what we call smart textiles is highly interconnected with the e-textiles, electronic textiles, wearable systems, and so on. And if you remember, the first discussion about these issues came from Georgia Tech, when a professor there has fixed a motherboard of a Pentium computer inside the jacket. So the whole motherboard was in the jacket. And this was the first, let's say, indication of a portable e-textile. And of course, it's something we don't like. We like to take out the electronic equipment and to have textile-based electronics if possible. But by any means, even if we have electronic components or textile-based electronics, we need to power them. And one way is to have a cable to run and to have a cable connecting us to the power lines, or to have a battery. And if you have a battery, you have to charge the battery. And if you have to charge the battery, you have to take it out to wash it and to wash the clothes. And this makes a problem for the user. And as you said, for years we work in this field in textile-based powering of the electronics. And more precisely, we have the case of the piezoelectricity, where the bending of the fibers create a voltage. That means we have electric energy to power the electronic components. Piezoelectricity has reported first time in 1880 by Curie brothers. 1980, it has been reported 100 years later, piezoelectricity on polymers. So you have polymer materials that by bending, you have electricity. And just 15 years ago, we have piezoelectric fibers, piezoelectric textile fibers. You can use fibers, and by bending them, you can have piezoelectricity. However, there are some restrictions like aging. These fibers operate for some months and then they forget their role, and they have to be re-stimulated and so on. This was the reason we turned to the piezoelectricity. Piezoelectricity was first reported in your area in a city south of Izmir, Miletos. By Thales, 700 BC, they observed it, then they forgot it, and recently we have rediscovered it. Recently it means 300 years ago. The first electric generators were triboelectric generators. Finally, we concluded that yes, we can use the nano piezoelectric generators, small-scale piezoelectric generators, and they seem to work. Yes, we are very, very optimistic. We have very good signs that these piezoelectric generators are very, very positive, and they give enough energy to power some portable devices. And we have really a very good indication. And in a cooperation with your university, we had the experience of using very modern materials, and the results were really very good. And we are very optimistic concerning this issue of the use of textile materials in order to create electric energy for powering the devices. This is true, and we are very happy for this.
Evet, teşekkür ediyorum verdiğiniz detaylı yanıt için. Evet, katılımcılarımızın acaba var mı sorusu? Şu an ekrana düşen bir soru. Ama evet, dosya paylaşılacak mı? Bunu herhalde birlik sekreterliği değerlendirecektir. Kendileriyle oradan temasa geçerseniz bu konuda yardımcı olacaklarını düşünüyorum. Yani misafiriniz sunumunu bize iletti. Onu dağıtımı konusunda ya da web sayfasının konulması konusunda herhalde birlik sekreterliğimiz gereğini yapacaktır. Tabii ki konuşmacımızı almak gerekiyor. Evet, başka? Sanırım şu anda bir sorunumuz yok. Ekranda gördüğüm kadarıyla katılımcı listesinde oldukça iyi bir katılım sağladık bugün. Konuya oldukça iyi bir ilgi vardı. Ümit ediyorum Savas hocamızın vermiş olduğu bilgiler bizim için yeni rotalar çizecektir, yeni fikirler ortaya konacaktır. Hepinize katıldığınız için çok teşekkür ediyorum. Tabii ki Profesör Vasilyadis'e bir kez daha hazırlıkları için, emeği için, davetimizi kabul ettiği için teşekkür ediyorum. Bu ara yine çeviri hizmetini bize başarıyla verdiği için çevirmenimiz Sayın Kurşide Tercioğlu'na ve burada teknik alanda görevli Bünyamin arkadaşımıza da teşekkür ediyorum. Evet, bir başka toplantıda yeniden buluşmayı diliyoruz. Hepinize iyi günler diliyorum. Hoşçakalın.